Given a list, if I ask you to display all of its elements, you could do it using loops. I recommend using this intuitive way of accessing elements from the list. For num in number list, print num. See how convenient it is. The for loop fetches the first element from the list and assigns it to the iterator variable num, which is printed inside the loop. Once the for loop reaches the end of the list, it exits. The other way to do this is by using list indexing. First, get the length of the list. Now write a for loop with iterator variable that will serve as an index for the elements in the list. This way of accessing elements in a list is suitable for few programs that require list elements to be picked with a step size. You could also implement the same using while loop. To check if an element is present in the list, you can ask Python, is the element in list? It would return true if the element is present, else false. This lets us write this elegant code that checks if an element is present in the list or not. Alright, pay close attention to what I'm going to discuss now. Here is a program that creates a list and assigns it to list1 variable. I have this statement, list2 equals to list1. Now I change the third element of list2 to 100. Then I will be displaying list1 and list2. You would think that list1 would have 2, 4, 6, 8, 10 and list2 would have 2, 4, 100, 8, 10. Let us find out by running this program. Oops, looks like both the lists have 100 as the third element. How did this happen? To understand this, you have to know how lists are stored in computer memory and how Python accesses them. When we create a list and assign it to a variable, we are creating a connection from the variable to the list. Now, if we assign that variable to another variable, Python does not create a new list in its memory. Instead, it creates a connection to the original list object in the memory. So if you make a change to the original list, it gets reflected in both the variables, as both the variables are pointing to the same list object in the memory. Hope this made sense. If not, go back a minute and watch the video segment again. Alright, now how do we create a separate copy of the list in the computer memory? One way is to create an empty list and write a for loop fetching each item from the list and appending it to the empty list. The other easy way is to simply concatenate an empty list with the original list. Creating an empty list creates a new list object to which the contents of the original list are concatenated. I would recommend you remember this and use it wherever you have to create a copy of a list. Okay, I'm now going to show you a program that computes the average of elements in a list. I will do this by using for loop that keeps track of the count and running total. There you go, a pretty straightforward program right there. For num in number list, add the num to running total variable, and each time you enter the loop, increment the count variable. Compute the average and display it. Alright, let us look at an advanced program that uses multiple features of lists discussed in the previous lecture. Here is a hypothetical list of TAs of CS21. Every new semester, some of the TAs move on to other things and will have to be replaced. Some of them continue to be the TAs, and some of them join newly as TAs. Here is a menu-driven program that asks the user to pick a choice. When you pick the option to add a TA, the new TA name will be appended to the list. If you choose to replace the TA, you have to get the name of the TA to be replaced and get the index. Then assign the new TA name at that index in the list. To remove the TA name, you can use the remove method. And things might get a little complicated with TAs having the same names, but you can always find a workaround.